Hi, my name is Angie and I'll be teaching you about UML sequence diagrams. We'll start by explaining what a sequence diagram is and what it's used for, and then we'll create an example of our own. In this tutorial, we assume you have a basic understanding of UML. If you don't, click the link in the corner to watch our other UML videos and learn more. Sequence diagrams are a type of UML diagram that show how objects in a system or classes within code interact with each other. Particularly, these diagrams show interactions in the order they take place. In other words, they show the sequence of events. They're primarily used by developers and business professionals to document processes or understand the requirements of a new program. Now, before we get started, let's talk about how we're going to make our example. You could draw a sequence diagram with a pen and paper, but a diagramming application is going to make things much easier. Today, I'm using the diagramming software Lucidchart. If you'd like to follow along, click the link in the corner to access Lucidchart's website, enter your email address, and you'll have a free Lucidchart account in just a few seconds. It's easy to use, and you can follow along with me as we build a sequence diagram. First, we need a topic. For our example, let's diagram the interaction that happens at an ATM. The first step is to think of the parts that make up whatever your topic is. If you're diagramming a system, that would mean all the parts of that system. If you're diagramming code, that would mean all of the classes that make up the program. So in our case, what are the parts involved in an ATM transaction? A person goes to an ATM to get money, the ATM communicates with a bank server, and that person's bank account is then accessed. The ATM, bank server, and bank account are all a part of the ATM system. These three items are our objects. The person, on the other hand, is external to the system. Therefore, they're an actor. Actors are always outside the scope of the system. In a sequence diagram, actors are represented by stick figures, and objects are represented by rectangles. So first we'll drag out an actor and place him here on the left. This represents the person trying to get money. Then we'll add our objects alongside it. We'll start by naming this object ATM, because the person first interacts with the ATM. Then bank server. And finally, bank account. You want the objects to be placed in sequential order from left to right. Next, we'll need to add lifelines. Lifelines are the vertical dashed lines that show the existence of an object or actor over time. Moving down the lifeline means that more time is passing. So we'll drag out a lifeline for the actor and for each of our objects. Now that we have our base chart laid out, we can start to diagram the interaction between our actor and our objects. To start, think of all the steps that happen when you go to get cash at an ATM. The first thing you'll need to do when you get to an ATM is insert your card. That will be our first message. Messages show the information being sent between objects. Sequence diagrams show the order of interactions or sequences, and they do this by moving down the lifeline with each message. So we'll start with the first one at the top. Drag out a line that connects the actor lifeline to the ATM lifeline. Now give it a label, insert card. Next, the ATM checks with the bank server to make sure it's a valid card. We'll drag out a line and place it between ATM and bank server, just below the previous message line. We'll label this one verify card. The server verifies the card and sends a message back to the ATM. When an object sends a message back, this is called a return or reply message, and they're always represented by a dashed line. Return lines often move from right to left, but that isn't always the case, as we'll see in a minute. So we'll drag out another line and connect it from the server lifeline to the ATM lifeline. We also need to change the line from solid to dashed. Again, the dashed line represents a return message, or a message from the receiving object back to the requesting object. We'll label this message as card OK. After the card has been validated, the ATM will ask for a PIN. So we'll draw a line from the ATM to the actor and label it request PIN. Because this message isn't replying to an earlier message and is requesting information rather than responding, this message is not a reply message and will be denoted by a solid line. So what happens when the card is invalid, like when an inserted card is expired? This is when an alternative frame is used. An alternative frame symbolizes a choice between two or more message sequences. These choices are usually mutually exclusive. So in this case, the conditions are if the card is valid or if it's not. We'll drag out one of these boxes and place it around the two messages we just created. The upper portion of the box will be labeled if card is valid, and the lower portion will say else. This says that if the card is valid, tell the ATM and the ATM will request a PIN. If the card is not valid, the server will tell the ATM and the ATM will eject the card. We'll make two more messages that show the alternate interaction, labeling them card invalid and eject card. After the ATM has determined the card to be valid and requested a PIN, the user will input their PIN. Since the ATM requested the PIN, and this is the user's response to that request, this message will be a return message. So we'll make a dashed line from the actor to the ATM and label it PIN entered. The ATM will then ask the server if the PIN is correct. We'll draw a line to represent that interaction and label it verify PIN. Now we have the same situation as before, where we'll need to use an alternative frame. First, we'll create what happens if the PIN is valid. The server will tell the ATM the PIN is valid, and the ATM will ask the user how much cash they want to withdraw. So we'll drag out our alternative frame and place it around the two new messages, labeling the top portion if PIN is valid. Next, we'll add the alternative messages. The server will tell the ATM the PIN is invalid, and the ATM will eject the card. We'll continue to map out the rest of the interaction by creating messages and return messages until the transaction is complete and the actor has received their money. The user will input an amount and the ATM will start a transaction with the server. The server then asks the bank account if there are sufficient funds to cover the transaction. If funds are sufficient, the server will withdraw the amount and tell the ATM to dispense the cash. If the funds are not sufficient, the transaction will be unsuccessful. Finally, the card will be ejected after the cash is dispensed or the transaction was canceled. With our interaction complete, now we can add activation boxes. Activation boxes show when and how long an object is performing a process. This shows us at a glance when objects are active and when they're idle. So we'll drag one out, place it on the ATM lifeline, and fit the box around the first and last message on the lifeline. We'll do the same for bank server and bank account. Since, as we discussed before, actors are external objects, they don't need an activation box. Now we can easily see that bank account is much less active than the rest of the objects in this sequence. While this example is fairly simple, sequence diagrams can get even more complex. For example, if you're diagramming code, the objects might be labeled as the names of classes, and the messages might be the methods and functions used in the code. It all depends on what you need to diagram and how complex you need it to be. Thanks for watching this tutorial on sequence diagrams. Please subscribe to our channel to watch more helpful tutorials. Leave a comment if you have any thoughts or questions. And lastly, click on the link to create a free Lucidchart account and start making your own sequence diagrams today. Leave a comment if you have any thoughts or questions. Leave a comment if you have any thoughts or questions.
Sorry. Do it.
Do it now. Leave it right here.
Leave it.